Hello everyone, welcome to my channel. This will be my first official video that I'll be making, and it's quite an interesting one because I've decided to start with something that I've always loved to do. In terms of architecture, I've always loved, in terms of the infrastructure, I've always loved IPsec tunnels and the way they are designed and the way they function. In this lab, or in this tutorial, I'll be taking us through the design and setup of an IPsec tunnel between two sites. I hope you enjoy this. Join me. This is my first video, so I would implore you to like, subscribe, and also leave a comment if you feel there's something that's supposed to be part of this video that I did not mention as well, or if you reckon it's something you would want me to make a video on. Without wasting so much of your time, let's jump on the lab topology. All right, so believe you can see this topology. So here we're dealing with a setup that's logically looks to be situated in Canada and London. These are two branch sites that are looking to have IPsec sort of communications between them. And the way to achieve it is to first of all have ISPs set up their circuits at this very ends in Canada and in London respectively. Then these circuits will be set up, and basic connectivity will be you'll be able to have basic connectivity between Canada and London. Once this is established, then you can talk about tunneling. So in this lab, I've already gone a few steps ahead. I've set up the basic connectivity. I've configured the interfaces here with their various IP addresses. I'm not using any IGP for this. I just chose to leave this to static routes, just to simplify the process. I'm utilizing Cisco routers for this ISP connection. I've also configured them with their own IP address between them, and also the IP address between this link, that's the port 2 of the Canada FortiGate and the port 2 of London FortiGate. So the essence of this is we're trying to encrypt the data that is being passed through between these two branches. So before setting up this IPsec tunnel, you would notice that every traffic that goes through the London side to the Canada, the moment it gets into the internet, it gets blown up and anything can happen to it. Anybody can hack into this packets data, sniff into them, and do whatever it is they want to do, and it can be used as a basis for attack. So but once the tunnel is configured, it will be encrypted. The payload that goes across these two sites will be encrypted. That's one of the benefits of the IPsec tunnel. So without wasting so much of our time, let's jump into this FortiGate to first of all confirm that we have set up the necessary IP addresses. So here we go. I close this. I've already had that opened as well. So Canada, this is it. I close this, and on the interface side of things, you can see we have LAN tree, which is the link going down into the local area connection. That is this PC W12 and W25. that's in Canada. So we have them configured. I've also configured a DHCP server on that link, so the PCs that are connected to this Canada all receive IP addresses via DHCP from the FortiGate router. And I've also configured the link to ISP with the necessary IP address of 10.50.11.2, while this side has 10.50.11.1, which is the connection, the next hop for whatever it is you want to go to. I also have this management port. That's where I'm able to get this GUI. I'm able to log into this FortiGate to access and configure whatever I need. So this is just the management port. It's got nothing to do with this lab for now. It's just for management purposes. Under this interface side, I've also configured the zones. It's very important that you configure zones when you are setting up FortiGates. Most of the time, the zones, you would use them to apply the policies that you need to enable these devices go on the internet or access each other, as it may be, as this case may be. So I have my firewall policies as well set up, the basic ones. So we have from the inside to the internet, and from the internet to the inside. We can have basic connectivity. We will test that now just to see that we are able to ping across this, the devices from the Canada to London and vice versa. At the moment, we don't have any VPN tunnels, if you can see. Oh, sorry, I thought I deleted this once. I cleared all the VPN tunnels before, but all right. So at the moment, we don't have any VPN tunnels, so it's all nice and new. On the static root side of things, you could see that we have set up individual static routes pointed to the different subnets that we're trying to reach. So the first one is for the link between the ISPs. The second one is for the link. The second one is for the link between the ISP in London and the London branch as well. And this is for the subnets in London as well. So this is to ensure that we have basic connectivity. We don't have any OSPF configured. We don't have any BGP configured for this lab. Okay, so over at London, we have the same thing, similar, and everything is in order as well. We don't have any VPNs configured. So now let's go ahead and test. Let's go ahead and test connectivity, basic connectivity between PC 12 and PC 20. And that's PC 20. So I'll just go. By the way, this is a virtual PC. I also have a Windows PC there. I have a Windows PC there that I could also use as well to do this test. So for now, let's just test this. So I have a ping to 192.168.20.20. Yes, we have basic connectivity. So I will do that as well from this Windows PC. And with that, we have something called the VNC. Expand that. Expand that and open up the command prompt and do a ping to 192.168.10. No, that's .20.20. Yes, we can. So we're golden. So we are able to establish this connectivity, this basic connectivity. The next thing we want to look at now is setting up this IPsec tunnel between this site and this site. So physically, we have set up the underlay. The underlay network is going to go from. Hang on, let's do a trace route first. So the underlay network is going to go like this. If you do a trace to 192.168.20.20, so the underlay network is like this. So the first hop is the 10.10, the 10.1, which is the Canada interface. the Canada inside interface, and 10.50.11.1, which hits the ISP. It goes across as well, the ISP, over to the London ISP, then down from London and straight to the PC over there. So what we're trying to achieve with the overlay network right now is, if it pings, if you run a ping from this zone, it hits this Canada router and goes across this tunnel on this 10.0.7.3 subnet and down to this PC. So let's jump in. I'm excited. In the process as well, we could notice some sort of things that will require us to troubleshoot. So I implore you to stay with me. We'll troubleshoot this together, get it solved and sorted, and at the end of the day, we would have a working VPN IPsec tunnel, side to side, basically, that we can learn from. All right, let's go on. So first of all, let's start with this Canada. And the first thing I want to do is to go over to the VPN tunnels. You can achieve this two ways. You can achieve this by using the CLI, and you can achieve this as well by the GUI, but the GUI is quite easy to comprehend. So let's not even jump on the CLI, so probably gonna get confused in the process. Alright, so just get this, set up a custom IPsec tunnel. You can give it a name whatever you want, but in this case I'd like to maintain some consistency. I would have to like to have some consistency, so I would use the ID for the FortiGate in London. So I would say LON FG02, and yes, it's an IPv4 static IP address, the remote gateway IP address. In this case, we are in Canada and London. We are dealing with this subnet. So London, this is where the remote IP address is. So that would be 10.50.22.2. Let's confirm that. So I jump into London FortiGate, and we can see we have 10.50.22.2. This is the IP address that we need. There you go. So I set that out. The interface would be linked to ISP. So yeah, that's the interface that I want this to go from. The transport will be, leave that in auto. Not traversal, I prefer to disable this. This bit, the dead pair, it should be on demand. Let's see. So the pre-shared key. So here is where you specify a pre-shared key that you want to deploy. The IKE version, the Internet Key Exchange. I think that's where it is. Please remind me what that should be. I think that's the internet key, something here. So we're specifying that. All right, so in this place will be so here we'll be specifying the pre-shared key, specifically version 2 of the Internet Key Exchange. Just for the lab, just for the sake of this lab, I'd like to keep it simple so it doesn't get a bit confusing. I'll be using Cisco 123. The Internet Key Exchange is very important that you choose the version 2 because it's kind of it is covered of most of the limitations that the IKE version 1 had, so it's more robust and secure to actually use. Now let's set up the phase 1 proposal. In this context, I'd like to check out a lot of them, and sorry, I add another one. I would like to use the DES and MD5. Nah, leave that. It's no longer recommended. Let's use the SHA-256. On the second bit, I want to use 5.2 encryption, and for the Diffie-Hellman group, it's recommended that you use between 14 upwards. From 1 to 5 is not recommended, so I would use 19 in this case. And that is it for phase 1. Now let's get phase 2 started. For phase 2, the same thing. The name will be the same. You can set a comment if you want. I'd leave it at blank. It's a tunnel mode and IPv4. Yes, I'll leave all this the way they are. Scroll down. Here I just want to set one authentication. That would be the DES and SHA-256. Perfect secrecy. Just want to disable this one for now. Yeah, I mean, when you are doing this in a live environment, you can choose to keep whatever settings that you want to keep. Perfect forward secrecy is actually very, very important. However, it can be memory intensive as well on the router, and at the moment we don't want to keep that on. Disable replay detection as well. So but automatic keep alive, I'd like to keep it enabled as well. And the key lifetime, that's okay. Auto negotiation disabled. Yeah, that if you're trying to set up a hub and a spoke kind of IPsec tunnel, you can check this and set all the parameters that did it. So okay, this okay. And yeah, you've gone through the first phase. Now the next thing we want to do is go over to the interface side of things. That IPsec tunnel would have already been included under the link to the ISP port 2 because we specified the interface there. So click on it, edit. And in this case, recall we've set an IP subnet that we want to use for the tunnel. So now it's time to assign it. 10.0.7.3 is the first one. So I do 10.0.7.3, and the remote IP will be 10.0.7.4 with a subnet mask of /31. I like to allow pings only. And yep, I say okay. Now, once this is set up, the next thing you want to do, we've done this bit, we've done the other bit. So now I want to set up the zone. So create zone. I call this IPsec. Call it IPsec, and I put this guy in there. Say okay. Now I have it in the zone. The next thing I want to do on this router is go ensure that I have a policy set up for this one as well. So again, I'm using an eval license for this FortiGate. So I have a limited amount of policies and static routes and whatnot that I can do. So I think I only have 3 thereabouts. So I will have to be rationing. That'll be the case. So I create new policy, or rather I'll close this first. I'll edit this one because from the internet now I want it to go from IPsec to the inside, and I say okay. So I've changed the first one. The second one I want to set is going to be from the inside to IPsec tunnel, and I'd like to see for this lab topology I want to allow all. Of course, when you're doing when you're setting this in the live environment, you might be required to specify the protocols and whatnot that you would like to allow to go through the tunnel. Do that and say okay. I'm okay with all the other parameters there. Now we have done that. We've set up the VPN tunnel. We have edited the interface and assigned the IP address that we wanted to be, that we required to be as part of the VPN tunnel. And the next thing we want to do now is a static route. So I go over to static routes. You know, I'll leave this first. So this might be the last thing we do. So let's go over to London. I'll probably blow through this one. You can try and slow down the first one, because I'll probably speed up this one so we don't spend so much time on it. It's the same thing that I've done on the first FortiGate that I would do here as well. So if we go over to the Canada side of things, we look at the interface, we can see that we have the IP address here as 10.7.3. So here would be 10.0.7.4, and the remote IP address is 10.0.7.3, and it's /31 max. I'd like to only allow access to ping. So hit OK. Yeah, so we've got this set up. So now let's go ahead and set up a zone. Just like the last one, I call it IPsec, and I pop this in. Hit OK. And now let's go over to the firewall and policy side of things. Edit this one. IPsec, okay. And create new. This will be from the inside to IPsec. The source, as usual, would allow everything. Allow all services. Again, you can choose whatever services you want to allow, but for this lab, for the lab purposes, I'll just allow everything. Yep. So we've set this up. So we have our tunnel. Voila. Yeah, you get proud when you get set up some things, and it works just the way you want it. You feel like a warlord. All right, so we have a tunnel. However, if you still do a trace route from, if I still try a trace, you can see from this, it's not going through. Yeah, it's not going through. It got to 22.2 and it stopped. Yeah, because why? Let's find out. Network. Static routes. We have it here. Network. Static routes. We have it here. But why? You keep asking yourself why. Okay, yeah, this is why. We have changed the policy. Yeah, we've adjusted the policy, and there's no policy for backwards, for reverse communication. There's only policy for inside to internet, and that's not enough to have a full conversation. So it's not complete. So the only thing we need to do now is to properly tell this router that whatever kind of the conversation you want to have between yourself and that subnet, you have to use the tunnel. So in this place, we go over here and specify this as the interface to use, and click OK. And go over to this one, edit this bit, and say for whatever conversation you want to have with that guy, go through this way, go to the tunnel, and hit OK. Now with this, we should have all right, guys. So as you can see now, we have the first hit from this VPC's perspective. Let me bring the topology so I can explain this out for you. So now we're pinging from this, and you can see the first hit is the Canada port 3, and from there it jumped into the tunnel, and voila, we're here. So we have a working IPsec tunnel. As we can see, we have completed, or we have completely designed and set up an IPsec tunnel between Canada and London. And this is the goal. This is confirmed. IPsec tunnel set up, all life and secure. All right, thank you very much for watching this channel. All right, thank you very much for watching my video. If you enjoyed this, if you feel there's something I need to add to this, please feel free to leave your comments in the comment section. That would help me improve as well as I deliver on this sort of tutorial videos. This is my first, and I know it's not going to be my last. I'll keep making more. I'll keep doing more of it. But your likes and your subscriptions will encourage me to do more of this. I'd like to thank you for viewing and have a wonderful, nice day. Thank you.